So, what if you could give an AI like GPT a quantum-powered upgrade? And I don't mean in some far-off future, I mean like right now. Well, a new paper called QuaTLAS is proposing a surprisingly practical way to do exactly that, boosting AI performance by blending it with the wild world of quantum mechanics. Let's dive in and break down how this actually works.
I know. It sounds like pure science fiction, doesn't it? Taking one of these massive AI models and plugging it into the strange, powerful universe of quantum computing. But this isn't just a thought experiment anymore. This paper explores a real, tangible way we might get a quantum advantage in AI within the next few years. It's pretty cool stuff.
Okay, so to really appreciate just how clever this new solution is, you first have to understand the huge dilemma that's at the heart of AI development today. We've basically got two massive competing problems. Our classical AI is hitting a wall, but at the same time, quantum computing is really just getting started. So here's the pickle we're in. On one hand, our best AI models are becoming just astronomically large, right? They're incredibly expensive and slow to train and run. Now, on the other hand, you have quantum computers, which promise this way out with exponential speedups. But the catch is, the hardware we have today is just not big enough or reliable enough to run an entire large language model. We're kind of stuck between a rock and a hard place.
And this is where the researchers behind QuaTLAS had a really brilliant idea. They thought, okay, instead of trying to replace the whole system, what if you just augment it? Their solution is a super clever hybrid approach for right now.
The core idea is actually pretty simple. Just let each type of computer do what it does best. All the heavy lifting, the stuff we're already really good at, that stays right on our trusty classical computer chips. But for one very specific, very targeted task, we offload that little piece of work to a small quantum circuit to get a unique advantage you just can't get anywhere else.
And you can see how this works right here. Instead of trying to reinvent the wheel and build a whole new model from scratch, they just take an existing powerful AI and swap out one tiny component. In this case, they're swapping just one of the many classical attention heads with a brand new quantum one. It's elegant. And that really is the main takeaway here. Think of it like minimally invasive surgery for an AI. You're not throwing away the years of training and all the knowledge that's already baked into a model like GPT-2. You're just adding a new, incredibly powerful tool to its toolkit.
So you're probably wondering, what does this little quantum piece actually do? How does it provide that secret sauce? Let's get into how this quantum attention head operates.
All right, let's follow the data's journey. So everything starts out on a normal classical path. Then a small, compressed signal gets sent over to the quantum circuit. And this is where the magic happens. Thanks to a wild property of quantum mechanics called entanglement, the quantum chip can basically look at the entire sentence all at the same time, spotting connections that a classical chip might totally miss. Then finally, that quantum insight, that big picture view, gets fused back into the main calculation. It's a true partnership.
Here's a really great way to picture it. Imagine the AI's attention heads are like different camera lenses it uses to read text. A standard, classical head is kind of like a zoom lens. It focuses really tightly on how specific pairs of words relate to each other. But the quantum head, that's like a powerful wide-angle lens. It can see the entire scene, the whole picture at once, spotting these big, global patterns and long-range connections that the zoom lenses would just miss.
Okay, so it's a really clever idea in theory. No doubt about it. But does it actually work in practice? Well, the researchers put QuaTLAS head-to-head with a standard classical model to find out. And wow, the results are pretty compelling. On two different standard benchmarks, QuaTLAS significantly outperformed its classical twin. That's an identical model that just didn't have the quantum upgrade. Now, the key number to look at here is perplexity. You can just think of it as a score for how surprised or wrong the model is when it tries to predict the next word. So lower is always better, and as you can see, QuaTLAS got much lower scores on both tests. This chart here makes the difference crystal clear. This is for the WikiText-2 benchmark. The blue bar, that's our hybrid QuaTLAS model, shows a consistently lower error rate. That means better, more accurate predictions than the purely classical model, which is the orange bar. It's a clear win.
So a 10.5% reduction in error on a standard task like this, that's a really solid, respectable gain. It absolutely proves that the concept has merit. But it's the next result that is truly eye-opening.
Almost 31%? A 30.9% improvement? Now that is a massive leap in performance. This shows that for certain kinds of tasks, adding that one little quantum piece wasn't just a small tweak. It provided a fundamental, game-changing advantage. So, of course, that begs the question, why such a huge difference? Well, the LAMBADA dataset is specifically designed to test a model's understanding of long-range connections. It requires the AI to connect ideas from across an entire passage just to predict the final word. It's tough. And this visual, this shows us exactly why it did so well. This is basically a map of what the quantum head was paying attention to. You see those bright vertical stripes that just dominate the image? That's the quantum circuit identifying these crucial landmark words, like the main subject of a sentence, and then keeping them in focus for the entire passage. This is that wide-angle lens in action. It's a completely different, more holistic way of paying attention than the classical model could manage, and that is the key to that incredible 31% performance boost. So what does all this mean? Well, these results strongly suggest that the future of AI, at least for the foreseeable future, is probably going to be hybrid. It's all about intelligently combining the best of both the classical and the quantum worlds. And what's really cool is the paper even lays out a plausible roadmap for how we get there. In just the next few years, we could be running these exact hybrid models on real quantum computers through the cloud. A little further out, as the hardware gets better and more reliable, we could see even more powerful versions. It's a real step-by-step path from today's experiments to a future where fully quantum models might actually be a thing. But okay, let's pump the brakes just a little bit. It's super important to be realistic here. These impressive results, they all came from a simulation, not a real quantum computer, yet. And the really big question remains, will this advantage still be there when we scale this up to massive models like GPT-3 or GPT-4? We just don't know. There is still plenty of hurdles to overcome before this is ready for prime time. But even with those challenges, QuaTLAS gives us a really compelling glimpse of what might be possible. It shows us a pragmatic, clever path forward, suggesting that maybe the next big leap in AI won't come from a single revolution, but from a thoughtful collaboration between two totally different ways of computing. It really seems like the future of AI isn't classical or quantum. The future is hybrid.